All right, this is a perfect hashing example. So perfect hashing. So the idea with perfect hashing is that there's no collisions. So this is only possible if you, you must know the keys ahead of time. Right? So you know who's coming to the party, but you're not sure when they're going to show up. Right? So you can make a special seat for everybody. So let's say this was our data, and I'm just going to have some simple data, like I'm going to do bat, cat, and dog. So strings this time. So I need a hash algorithm. So I'll do h of the key is going to be, so these are the keys. I want to do, let's do, so we'll use a lookup table called G. So we'll have a lookup table called G, and this is going to be the alphabet. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And of course, those are really going to map to indexes. So we'll start at, we could start at 0, but let's start at 1 just to, sometimes that's easier to just. All right, 1 through 26. So what we'll do is we'll take the letter and we'll use that as an index into this table. And initially we can just put so these are indexes up here. Index, letter. Really, indexes. If you were coding this, you'd be using indexes, but of course those map to letters. And, you put 5. Right, just put we've got to have initial values in here. So they could be anything as long as they're different from each other, but might as well just put the index values in there initially. So we'll just take G of the first letter. So we'll take this B and then use that and pull out this 2. Okay, and then we'll add that to G of the second letter. Just the first 2 letters. It's kind of arbitrary. And then we'll take that sum and we'll modulo by 3 because my data store, I want to store this in a 3-element array. I want to be really efficient about this. So I want to just store this. I want the indexes 0, 1, and 2. I don't want to have any extra data. So let's see, let's do these calculations. So H of, H of bat is going to be H of B, plus H of A, the whole thing moduloed by 3. So it's going to be B is 2 plus A is 1. So it's 3 modulo 3 or 0. So this is 0. So H of the key for bat is 0. And, H of cat is going to be, it's going to be 3 plus 1 modulo 3. So that's, 4 modulo 3 is 1. So this cat mods to 1. And then dog, H of dog is, D is 4 plus O is 15. The whole thing modulo 3, so it's going to be 19 modulo 3, which is 1, right? Because 3 times 6 is 18. 18 goes in once with a remainder of 1. So this hashes to 1. Okay, so I have a collision here, right? 1 and dog hashes to 1 and cat hashes to 1. So I need to fix one of these things. And if I changed A, like if I changed the lookup value in A, it would break cat and bat, and those already are different. I don't want to break that. I could change D because the only D is in dog. I could also change G. I could also change O, right? Because all of those letters are unique to dog. I could change any one of them and it should be okay. So I'm just going to change this guy. And if I have a 2 available, right, 0, 1, I could put him in space 2, just make this into a 5. Right, so change the 4 to a 5, and then this will be a 5, and this will be a 20, and you'll get a 2 here, right? So this will become a 2. Okay, so bat will go here, and cat will go here, and dog will go here in the data store. Okay, that's perfect hashing. So it only works when you know who's coming ahead of time, and you can spend the time building an algorithm or a hashing algorithm that has no collisions. And so that's dependent on the algorithm itself. Here I'm doing first letter and second letter, and then the lookup. And sometimes you might have to change this. This happens to work for this data set, first and the second letter, because there's enough differences in these first 2 letters that it'd be okay. But if I had a bunch of words that had the same first 2 letters, then this algorithm wouldn't work. I wouldn't be able to fix it. If the first 2 letters were the same, I'd have to change this hash. I'd have to maybe use first and last letter, or I could use length of the word or just length of the word and the middle letter, or something like that. You just do something here, kind of pretty much not random, but something that's works for your data set, and it just depends. You have to think through it. Okay, moduloing by 3 is dependent on the data store. That's where the 3 comes from. But what you're doing in here is variable depending on the actual data values. Okay, I got another example that's in an Excel spreadsheet that I'll make another video about. All right.